In this video, we're going to talk about how we can use the matrix mode of a calculator to perform various matrix operations like multiplication, inverse, and so on, which can greatly help us in chapters like matrix algebra, linear algebra, and a few others in the UPSC CSE mathematics optional examinations. The matrix operations that we look at are multiplication of matrices, inverse of a matrix, finding determinants, solving system of linear equations. My calculator supports up to 4 variables. The calculator cannot directly find the rank of a matrix, but it can aid us in finding the echelon form fairly quickly. The calculator can be used to verify the Cayley-Hamilton theorem and also verifying the characteristic polynomial. We can also use the calculator to find out eigenvalues once we have found out the characteristic polynomial. The diagonalization, which forms a major component of the matrix algebra chapter, can be verified using the calculator as well. Now let us look at these operations one by one. So first let's look at multiplication. So to enter the matrix mode of the calculator, firstly we need to go to the menu, and then we need to go to the matrix mode, which is number 4. So here it will ask you to define matrices. So for example, suppose we need to find A into B, and the matrices are given as the matrices are given as A and B here, and we need to find AB basically. So let us define matrices A and B. So I'll press 1. Number of rows are 3, number of columns are 3 as well. The matrix elements are 1, 0, 2, 2, minus 1, 3, 4, 1, 8. Now I'll go to option, define matrix, matrix B. Number of rows are 3, number of columns are 3 as well. Minus 11, 2, 2, minus 4, 0, 1, 6, minus 1, minus 1. Now when we want to perform any calculations on these matrices, we'll go to option, number 3, matrix calc, and then again option, matrix A, 3 into matrix, or rather we don't even need to do that, into number 4, matrix B. That will give us this. So A into B is equal to 1 0 0 0 1 0 0 0 1. Now in the examination, we'll have to calculate matrix multiplication in plenty of problems. So how would we actually write this in the examination? So what I used to do was I used to write AB is equal to 1 0 2 2 minus 1 3 4 1 8 times minus 11 2 2 minus 4 0 1 6 minus 1 minus 1. And I straight away used to calculate this using the calculator and write it as 1 0 0 0 1 0 0 0 1. I never used to actually calculate it this way during the examination. So as in this way, as in manually, like 1 into minus 11 plus 0 into minus 1. So I think this is a much cleaner way, and this will fetch you the same number of marks. And matrix multiplication will be used in plenty of places. So I would suggest that you use this. Similarly, we can also calculate multiple products like matrix A into B into C. Everything can be done in this fashion. So yeah, that is matrix multiplication. Now let's move to inverse calculations. So while inverse calculation we cannot do it directly using the calculator, as in we'll need to show some steps during the examination. We can easily use the inverse to verify the calculator to verify our inverses. So for example, we need to in this question we need to use elementary row operations to reduce this matrix into the echelon form and find the inverse of A. So we will find the inverse of A using our usual methods, and then we will use the calculator to just verify whether our inverse is correct or not. Because I think matrix algebra is a very easy chapter, and we need to make sure that whatever we are doing here, firstly it takes very less time to solve during the exam. Then we have to make sure whatever we are doing here is correct, because these are very easy marks. So again, if you have to find the inverse of A, let's try that. So we will go to option, define matrix. Let's define the matrix A, 4 rows and 4 columns, 2 1 3 0 3 0 2 5 1 1 1 1 2 1 1 2 1 1 3. So 2 1 3 0 3 0 2 5 1 1 1 1 2 1 1 3. Right. Now again we'll go to matrix calculation, matrix A, and then here we see x inverse, right? So matrix A inverse is equal to, so this is our inverse. So basically after we calculate the inverse by using whatever Gauss-Jordan method or whatever we want to use, we can verify the inverse from the calculator using this and make sure that whatever we are doing is correct. Next, let's come to finding determinants. So finding determinants is also pretty simple. So how I used to do this in the exam is that we know how to find the determinant, right? So we take this. So determinant of A is equal to 1, 0, 2, 2 minus 1, 3, 4, 1, 8 is equal to. So sometimes, so here if you see, right, that finding determinant of A and determinant of B is a separate question altogether. So I think it will be nice to write a step here. So 1 into minus 8 minus 3 plus 0 plus 2 into 2 minus 4. I should write like this, and instead of calculating from here, I just used to use that from here. So again, option define matrix A 3 3, because you know these things are very prone to making mistakes. So 0 2 2 minus 1 3 4 1 8 matrix calc. Now if we come down, we'll find determinant. So determinant of matrix A, and then close the bracket, and you'll get determinant of A is 1. Similarly, determinant of B can also be found, right? So this is how we can find determinant. Now this is a direct question of finding determinant, but in many places you will need to find determinant, and I think we can directly use the calculator to write it down. So determinants are done. Now we'll come to system of linear equations. Now system of linear equations are generally in the form of okay, let me just get the, so it's generally of the form of Ax is equal to B, where A is some coefficient matrix, X is X, Y, Z, suppose we have 3 variables, and B is the constant vector. So how we find X is A inverse B if A is non-singular. So either we can find A, so we know A, we know B. Either we can find A inverse and then find A inverse B. So for example, I'll give you an example, or we can use a different method which I'll show as well. So first we need to, so this question was a part of the CSE 2013 paper, and it says that we need to find the inverse of this matrix by using elementary row operations and solve the system of linear equations. So firstly, if you see, the system of linear equations has the coefficient matrix A as 1 3 1 2 minus 1 7 3 2 minus 1 from here. So this is 1 3 1 2 minus 1 7 3 2 minus 1, right? So this is our coefficient matrix. Our variable matrix X is X, Y, and Z, and our coefficient matrix B is 10 21 4, and basically they're asking us to solve A X is equal to B. So if determinant of A is not 0, then X is equal to A inverse B. And so here they're asking us to find the inverse of matrix, so they're asking us to find A inverse basically. So after we find A inverse, we'll be able to solve the system of linear equations by multiplying A inverse by B, right? So firstly, let me just say how you'll write this in the exam. So first you'll use the elementary row operations to find A inverse, right? A inverse is found, then we know the B, and we'll say, so the solution of the system of the linear equation is A inverse B, which is equal to something, okay? Now, how will we verify it or use the calculator to solve it? So after we have found A inverse using elementary row operations, we can quickly use the calculator to see what A inverse is and verify it. So I'll go to options, define matrix, matrix A, 3 rows, 3 columns, 1, 3, 1, 2, minus 1, 7, 3, 2, minus 1. Let me quickly verify. 1, 3, 1, 2, minus 1, 7, 3, 2, minus 1. And matrix B, let us define matrix B as this coefficient matrix. So 3 rows and 1 column, 10, 21, 4. Now, when we perform matrix calculation, so firstly we'll find out A inverse. So 3 inverse. So we found out that A inverse is this. Now here it might show you something, some decimal number, but if you go to that point, it'll show you it is minus 13 by 63, 5 by 63, 22 by 63. So this is what A inverse is. So you can verify it from here. And now let's calculate A inverse B as well. So 3 inverse B. So that will give us 1, 2, 3. So actually the answer should be 1, 2, 3, which you can verify using the calculator. There is one more way to solve linear equations using the calculator. Let me quickly show you that as well. So if you go to menu and go to the equation function mode, so you need to press A, or you can go down and click on this. There it will show you simultaneous equation. So click on simultaneous equation. Number of unknowns are 3 here, and the equations are 1, 3, 1, 10, 2, minus 1, 7, 21, 3, 2, minus 1, 4, equal to, so it will tell you x is equal to 1, y is equal to 2, z is equal to 3. This is one more way. This can be very useful in problems of analytical geometry and all, where you do need to solve equations of 3 variables. And in most cases, you don't need to show the working of your solvents. You can directly use this mode to solve the linear equations. But in this particular problem, we are asked to do it using matrix. So we can verify using this mode of the calculator, but we cannot write this like this in the exam directly. So yeah, this is about the system of linear equations. Now let's go to rank of a matrix. So I'm going back to the back to the normal mode for this. So the rank cannot be directly found using the calculator. If it was possible, then it would have been great, but it's not possible right now. So we can make our life slightly easier while calculating echelon form, because for finding out the rank, we need to find out the echelon form of the matrix, right? So if you remember that in finding the echelon form, we need to make a lot of row operations, like say R2 becomes R2 minus 5R1 and so on, right? Now this part is also very prone to making mistakes. So we're very prone to making mistakes in this part as well. So that's why I at least used to use a calculator to verify what I was doing. Let me show you how we can do this. So we need to find the rank of the matrix A, where A is equal to. So let me just copy this matrix down here. So A is equal to 5, 7, 2, 1, 1, 1, minus 8, 1, 2, 3, 5, 0, 3, 4, minus 3, 1. I'm just going to show you maybe partly how to do it. So what we need to do here is that we need to first make this as 0, make this as 0, make this as 0. So what we're going to do is R2 implies R2 minus R1 by 5, R3 becomes R3 minus. You can also use different methods which might be easier. I'm just showing you one. So what will this become? 5 R2 R1 by 5, and R4 becomes R4 minus 3R1 by 5. So now calculating this by yourself becomes very tedious. So what I'll show you, we're going to use the solve method of the calculator here. So let R1 R2 be A and R1 be B. Okay. So what I'm going to do is go to the alpha mode, right? So I'll say A minus B, so alpha again, B divided by 5. Okay, so this is what we want to call, we want to solve R2 minus R1 by 5. Okay, and I'm going to go to shift and say, sorry, I'm just going to press calc here. Okay, so now we can give in values of A and B and it will tell us what is A minus B by 5. So here firstly A is 1 and B is 5. So we get 0. So I'm going to write that here. So 5, 7, 2, 1, 0. Next, A is 1, B is 7. So that gives us minus 2 by 5. Next, A is minus 8, B is 2. So minus 42 by 5. Next, A is 1, B is 1, 4 by 5. It is slightly difficult to get used to this at first, but once you get used to it, it becomes quite simple. Now we have to make R3 is R3 minus 2R1 by 5. So we want to make it as A minus 2B by 5. Right? A minus 2B by 5. Again, calc. So now A is 2. So we're going to do the R3 portion now. So A is 2, B is 5, which gives us 0, which we want exactly. A is 3, B is 7. So, sorry, so now I've made some mistake here, so I have to go back again now. Yeah, so calc, A is 3, B is 7, which gives us 1 by 5. Next, A is 5, B is 2. So A is 5, B is 2, which gives us 21 by 5. Lastly, A is 0, B is 1, which gives us minus 2 by 5. And for the last row, we need minus 3R1 by 5. So we'll change this to minus 3R1 by 5. Calc, A is 3, B is 5, which gives us 0. A is 4, B is 7, which gives us minus 1 by 5. A is minus 3, B is 2, which gives us minus 21 by 5. A is 1, B is 1, which gives us 2 by 5. Now we don't need to use the calculator. We can see that R3 is minus R2, R4 is minus R2, and R4 is is 2R1. So ultimately we can do the following operation. So R3 is R3 plus R2 by 2 and R4 is R4 minus R2 by 2, which will give us, ultimately these two rows will become 0 and we'll get the rank as 2. So this is how we can calculate the rank of the matrix. You can try that for yourself. So I think this becomes slightly easier because we don't have to worry about calculation errors here anymore. Now let's come to the Cayley-Hamilton theorem and characteristic polynomial. Now the mode cannot directly be used to calculate the characteristic polynomial, but it can definitely used to verify and calculate eigenvalues as well. So for example, in this question, for this matrix, we're asked to obtain the eigenvalues and the value of this function. So how we obtain eigenvalues is, firstly, we need to find the solution to this, right? Minus 1 minus lambda 2, 2, 2 minus 1, 2, 2, 2 minus 1 minus lambda minus lambda. So that gives us minus 1 minus lambda whole cube, 1 plus lambda whole cube I'll just write it more clearly, sorry. Minus 2, so this will give us minus 2 lambda minus 4 plus 2, 4 plus 2 plus 2 lambda, which will give us minus 1 minus lambda, 1 plus lambda square plus 2 lambda minus 3 minus 2 minus 6 minus 2 lambda plus 2 6 plus 2 lambda, which is equal to, so we have minus of lambda square plus 2 lambda minus 3 plus lambda cube plus 2 lambda square minus 3 lambda so plus 12 plus 4 lambda plus 12 plus 4 lambda, which is equal to, so this is going to give us lambda square plus 3 lambda square, so minus 3 lambda square minus lambda minus 3 plus lambda cube plus 24 plus 8 lambda, which is minus lambda cube minus 3 lambda square plus lambda plus 3 plus 24 plus 8 lambda, so which is minus lambda cube minus 3 lambda square plus 9 lambda plus 27. Now to solve this, we will go to menu, equation function, polynomial, degree is 3, so minus 1, minus 3, 9 and 27. So x1, 3 minus 3. So it will give us roots are 3 and minus 3. And since this is a now this is a kind of a polynomial that has repeating roots, because we get the values is only minus 3 and so x1 is 3 and x2 is minus 3. So we need to see which of the roots are repeating. So if you see the product of roots, if you know, so sum of roots is minus b by a, sum of products is c by a and minus d by a. So product of roots is minus d by a, which is 27. That means the negative root is repeating. So we have minus 3 as the, these are the eigenvalues. So we have used the polynomial function of the calculator to calculate the eigenvalues. Now we need to calculate the value of a power 4 plus 3a cube minus 9a squared. Now in the exam, you will use the Cayley-Hamilton theorem only to calculate this. I'm not going into the details of how you would solve this, but for verification using the calculator, you can use this. So for example, menu, matrix mode, define matrix, matrix A, rows 3, columns 3, minus 1, 2, 2, 2, minus 1, 2, 2, 2, minus 1. Now we need to calculate the value of this. We need to verify the value of this. So 3 matrix calculation, matrix A now square. You cannot directly raise it to a power greater than 2. So I'm going to do it like this only. sorry, plus 3 matrix A cube. So matrix A square, matrix A minus 9 matrix A square. So this will give us the actual value of this that we need to find. You need to use the Cayley-Hamiltonian to find this, and where you can verify it using the calculator simply. This is how we can solve or verify the Cayley-Hamilton theorem.